Welcome to my channel, Chemistry Class. Good morning, everyone. Welcome back to Chemistry Class. Dear student, before we start, let me ask you: when you look at a periodic tables, have you ever thought, or are all atoms the same size? Of course not. Tiny hydrogen atom is much smaller than a like uranium atom. But here is the interesting part. There is a pattern and how atomic size changes as you move across a period or down a group. Dear student, today we are going to learn one of the most important periodic properties, which is atomic size, which includes atomic radius and a covalent radius. By the end of this lectures, you'll be able to explain how atomic size varies and the periodic tables and why. Now, what is atomic size? Dear student, atomic size means how large an atom is. How large an atom is. But wait, an atom doesn't have a sharp boundary like a bomb. Electrons are in constant motion around the nucleus, so scientists define size in terms of radius. So, atomic size is the distance from the center of the nucleus to the outermost electron clouds. Now, dear student, we can't measure at exactly like we measure a cricket's balls, but we can estimate it from bonding distance. Now, atomic radius. Atomic radius. Radius student? Atomic radius as the distance from the center of the nucleus to the outermost electron shell in an isolated atom. Range of atomic radius and periodic tables. Radius ring across a period left to right. Atomic radius decreases. Why? Large number of protons increases, nuclear charge increases, and electrons are engaged in the same shell, so they are pulled closer to the nucleus. As a result, size or shrink. Size or shrink. So that's why atomic radius decreases across a period in from left to right. Now, atomic radius and down a group mean from top to bottom. Atomic radius increases. Why? Because new shell or edit, so the distance between nucleus and outermost electrons increases, and even though nuclear charge increases, the effect of extra shells dominates. As a result, size grow. That's why atomic radius increases down a group in from top to bottom. Now, examples of atomic radius. In lithium, radius is greater than beryllium's radius, greater than boron's radius in the same period. Mean decreases. Atomic radius decreases across a period. And group 1, lithium less than sodium less than potassium, in size increases down a group. See, this is a atomic radius you increasing radius from top to bottom in a group and decrease and a period from left to right. Now, my dear student, equivalent radius. Equivalent radius. My dear student, half of the distance between the nuclei of two identical atoms joined by a single covalent bond. Because isolated atoms are hard to measure, scientists often measure the bond length between two atoms and then take half of it. Example, in a chlorine molecule, Cl2, distance between nuclei is equal to 198 picometers, and the covalent radius is equal to 198 divided by 2 is equal to 99 picometers. Now, trains of covalent radius. It is train covalent radius show the same trains as atomic radius. Across a period decreases and down a group increases. You see, covalent radius and down the group increases, and from left to right across a period decreases. Now, my dear student, why is atomic size important? Because it affects reactivity of metals and non-metals. It explains why some elements form strong bonds and other don't. It is the key to understanding ionization energy, electronegativity, and chemical bonding. My dear student, this is all about today's lectures. If these lectures help you, then don't forget like the video, subscribe to the channel for more chemistry lectures, and share it with your friends and comment your questions below. Thank you for listening.